So in the last class, I discussed the wave winding and how to write the winding table for that, and you have been asked to draw the radial form diagram and also the brush position. So I think you have understood the thing. Now, in the last class, I told you that what is the different application of these two types of winding, that is wave and lap winding. Now, lap winding, as I told you, that lap windings are preferred for the machine having low voltage and high current, as it gives more number of parallel paths. And the wave winding is preferred for generally for high voltage and low current machine. Now, this wave winding is also called the series winding. Some in some literature, it is also called series winding because most of the coils are connected in series. Now, these lap and wave windings are also used for AC machine, not only in DC machine, but in AC machine also the lap and wave windings are used. Now, here you have seen that to start the design, the main important factor that is the back pitch and also the commutator pitch. And commutator pitch also determines that whether the winding will be simplex or multiplex winding. Now the difference, another difference in you can say the disadvantage of lap winding. I mentioned in the last class that the lap winding uh, may have some different voltage differences in the different parallel paths. Now, if the voltages are different in different parallel paths, now I discussed that how the circulating current will flow. Now, this circulating current not only will flow through the coil and heat it up the uh, armature, not only that, but also it will flow through the brush and it will create some commutation problem and also the sparking at the brush contacts. So therefore, these are the problems of this voltage mismatch in different parallel paths in lap winding. So generally, we use the equalizer connection, uh, which a little bit equalizes the voltage in all the parallel paths. Now, what is the equalizer connection? I will discuss today. So before that, we should know that why that difference. That means that why the voltages are different in different parallel paths in a lap winding. Generally, what happens? The voltage, the expression of voltage, you know that uh, for total it is ZA by AP phi, and that expression I think you have you can memorize that expression. So ZA by A, P phi and N. So where ZA is the total number of conductor, A is the number of parallel path, P is the number of pole in the machine, flux phi is the flux per pole, and N is the small n is the revolution per second, the speed, angular speed in revolution per second. So this gives the total voltage EA or induced voltage EA. Now in each parallel path, you will get no, you won't get this voltage, but it's a different voltage anyway. And also a particular coil will give a different voltage. The voltage given by a particular coil will be less than this voltage. But anyway, whatever the voltage generated in one coil, that depends on the flux. Okay, so as this term is already there, so this term determines, also we have discussed during the voltage this expression derivation, that how this flux determines the voltage induced in a coil. Now this, if this flux is different, at a particular instant, if this flux is different for different coil, then the voltage which is induced in that coil will be different. Okay, suppose if we see, if we uh, go back to our previous discussion in some lap winding radial form that you have, I think. Okay, so I can also discuss. Okay, so let's see this. Here, a set of coil is there under North Pole, and set of coil is there under South Pole. So under North Pole you have three, and under the South Pole you have three, like this. Now, if there is some mismatch in flux per pole, so that means the flux per pole is completely the parameter of the pole. Not only that, not only pole, the pole generates the mmf, but the flux also depends on the air gap. Okay, so air gap between the armature and the pole. So these are the parameter which determines the flux, how much flux will link a particular coil. Now, if a particular coil is under the now North Pole, and if another coil is under the South Pole, it may so happen that the voltage which is induced in the first coil is different from the voltage which is induced in the second coil, as it is under the South Pole. Why? Because the flux per poles are different. Why the flux per poles are different? Because uh, due to some manufacturing error, manufacturing defect, there will be slight mismatch in the parameters of the poles. Okay, so it is not always possible to make all the poles exactly same. It is not possible. Sometimes during the winding also there may be some error. So due to this type of problem, there may be some mismatch in the parameters of these different poles. Not only that, sometimes the air gap, that means the gap between this pole and the armature. So that particular distance is called the air gap. So let me draw that, then you will understand this. Now, air gap, what is air gap? Suppose you have the North Pole or any pole, and you have the armature here. Okay, so this is the armature which is rotating. So this gap is called the air gap. The distance called the LG. So length of the air gap. So this length of the air gap uh, is very important one, because it's that is different at different location. Then there may be some reluctance difference, because as you know, that flux is not only depend on the mmf, it is also depend on the reluctance value. So this Lg determines the reluctance. This air gaps determines the reluctance. If Lg is different under different poles, then the flux per pole for a particular pole can be different. Okay, so due to this, there may be some mismatch in the flux value under different poles, and that will be reflected in the voltage generated under a particular parallel path. Now, in a particular parallel path, you have seen that there are multiple coils also. Okay. Now, if we can balance this, that means how we can balance this. Suppose, as we have seen in some lap winding we have drawn, so we have 12 coils there. So like this, one parallel path. So another parallel path is like this. Okay, so these are all parallel paths, and you can connect this like this. These are the brushes, and you have seen not only two, there will be four brushes for lap winding. Anyway, I'm drawing only two, because brush will ultimately short the thing. Okay. Now, if what will happen, what equalizer connection does, it connects or it joins two two points. You can say 2 points in two different parallel paths, which are supposed to be at the same voltage. So that means, suppose this particular coil, if it is supposed to generate 2 volt, that you know that one coil will generate 2 volt, this coil also will generate 2 volt. So that means these 2 point supposed to generate the same voltage. Okay. Now equalizer connection connect these 2 points. Okay, so if there is some mismatch in the coil voltage, so it will create a path in that, but that is not huge, because these voltages are very less. Now, if this circulating current is flown by the total path, then it will be large. The current will be large. Not only that, the current can flow through the brush as well. Now, if the current flows through the brush, then there will be some commutation problem. Sparking can be created. Okay, so this type of connection is called the equalizer connection. Now, sometimes this type of connection generally done at the other end of the commutator. That means at the overhang end of the commutator. No, not only, sorry, end of the coil, not at the commutator end, because it is easier to make the connection there. Now, sometimes the equalizer connections are done in form of a ring. Then it is called the equalizer ring. So I don't have many figures on that, but I can show you some equalizer connection. So let me find if I have some figure on this equalizer connection. So I have, let me see. No, I'm not getting. Okay, so here in that, okay, so one of the connection I have seen in the website, so I'm just sharing that. Can you see this? So this is one kind of
Yes, sir.
equalizer connection, but not in form of ring, but it's an equalizer connection. So this is how they short uh, uh, similar point in different parallel paths. So equalizer connection basically a shorting connection, which short similar points in different parallel paths. That's all. Okay. Now go back to our discussion. So this is about the equalizer connection. Now, one more thing I uh, told you last day, that though that is not there in details in your syllabus, that is another type of winding is there, apart from this uh, wave and lap winding. Another winding is there, that is called the frog leg winding. though it is rarely used because of the complexity of this winding. But what it does, it combines the advantages and disadvantages of uh, wave and lap winding, and it consists of both the lap and wave winding in a same machine. The same machine, it has both the lap and wave winding. Now you will say that suppose if the machine is four pole machine, now the lap winding gives generally four parallel paths, but the wave winding will give two parallel paths. So how it is possible to connect? Now what it does, suppose it's a four pole machine. Now in case of duplex wave winding, the number of parallel paths becomes two. Okay, so that means in case of four pole, sorry, it's not two, it's two into two.
Sir, 4.
Okay, so it's two into two, that means a four, not twice p. And the lap winding already gives us four, so then it matches. So this is how it matches this wave and lap winding. So it uses a duplex wave winding and a lap winding. So this is how it becomes four, in both the cases, four parallel paths, and ultimately it gives eight parallel path. Okay, so twice p parallel paths, and I will show you one of the frog leg winding. Let's see if I have some figure. Just a minute. Let's see. Okay, so I have one. Can you see this? So this is a 22 slots frog leg winding. So there are 22 slots. Not only that, you have 22 commutator segment as well. Now each slots has four coil sides. Two coil sides are for lap winding and two coil sides are for wave winding. Now here in the figure, in the upper part is a duplex wave winding and the lower part is a simplex lap winding. Upper part is a duplex wave winding and the lower part is a simplex wave winding. So you can check that. Okay, and there are split phase level connection in the place to place. So there are 10 such connections where this lap and waves are made parallel. Okay, so this type of winding is called the frog leg winding, which combines the advantages of lap and wave winding. Okay, so let us go back to our discussion. Okay, now, so one more thing I want to point out here. Sometimes there are some slot or some coil side positions which the design which cannot be filled, that generally kept generally you cannot left vacant. Okay, so what it does, a dummy coil or dummy winding is placed in that position, that coil sides or the coil position. That is called the dummy coil. Dummy coil means that will not be connected with the original armature winding, the actual armature winding. But you cannot leave any location, any position on the armature slot blank. Okay, because that may create some mechanical problem, so mechanical imbalance. So to make up this mechanical balance, we generally place some dummy coil or dummy winding there. Okay, so why winding? Because that copper only the if you are using the copper coil in the rest of the slots, you have to use the copper winding there, because that copper only will have the same weight. Otherwise, it will create some mechanical imbalance. Though it will not take part in the armature current carrying, but it will uh, take part in the mechanical balancing. So that type of coil is called the dummy coil. So have you understood? Sometimes it may so happen that uh, some uh, uh, some coil side position or some slot you are not using. You cannot use uh, with the given number of coils. So then what we do? We place a dummy coil there. Similar coil, but we don't connect this to the original or actual armature winding. So that is called the dummy coil. Have you understood this point? What is dummy coil?
Sir,
Hmm.
yes, sir. So just little bit of the diagram that you gave as a homework.
স্যার স্যার
I mean, if you see
আরেকবার
this,
বলুন।
One by one. But the noise is coming. You just
yeah,
take care of that. Okay. So you may ask. You may ask. Actually, I have not
the
checked your.
winding diagram that you gave homework.
Okay. Is there any issue?
Yes, sir. So for as far as my diagram is concerned, three slots are there in which uh, direction of current is different. I mean, in one particular slot, coil side, for example, upper layer winding and lower layer winding, and direction of current is different for those coil side. Because if it is not possible for this is 15 coil side, I think. Yeah, this is 15 coil side and four number of poles. So this is not 15 divided by 4 will not give you integer, and that's why there is a lot of possibility that for in one particular slot
Hmm.
there may be possibility that you know coil side will two coil side will have different. So how it is possible? Because uh, it is rotating in the same direction. As far as one slot is concerned, magnetic field direction would be same. So how can it be possible that the direction of current will be different in two different coil side of a same slot?
No, it is not possible. But is it coming like that?
It is not possible.
No.
Yes,
Is
sir.
it coming like
It is
that?
coming like that. Yes, sir.
Okay.
I
So
don't know. I mean,
I have not
mine is
checked that.
coming. Other, I don't know.
আর কেউ কিছু কমেন্ট করবে এটার উপর? I have not checked your sheets.
স্যার এই পিএস ভীমরার বইয়ের একটা জায়গায় দেখলাম যে এই কেসটাই আলোচনা করেছে, যে যেখানে মানে কয়েল স্লটস পার পোলটা ইন্টিজার নয়, সেক্ষেত্রে যেটা ধরছে সেটা ওই মানে একটা এখানে যেমন 15টা স্লট 4টে পোল, তো একটা পোলের আন্ডারে 3টে স্লট, বাকিগুলোর আন্ডারে 4টে করে স্লট নিয়ে
হ্যাঁ, সেটা
নিচ্ছে,
হতে পারে। সেটা
সেইভাবেই
তো হতেই
করেছিলাম।
পারে। হ্যাঁ, সেটা হতে পারে। না, না, ও বলছে যে একটা স্লট, আমি যেটা ওর প্রবলেমটা বুঝলাম যেটা হচ্ছে
Oh, sir.
একটা in one slot two current directions.
Hmm.
That is not possible.
Yeah.
Either cross or dot you have to.
But for completion,
স্যার ভীমরাতে
yes sir,
একটা উদাহরণ মানে যেটা আছে সেটা 11টা স্লটস ছিল, 4টে পোল ছিল। হ্যাঁ, এবার কমিউটেটর মানে ব্রাশ তো সেখানেই লাগে যেখান দিয়ে দুটো কারেন্ট একসঙ্গে ঢুকছে বা দুটো কারেন্ট একসঙ্গে বেরোচ্ছে, এখানেই ব্রাশটা লাগে। কিন্তু প্রবলেমটা হচ্ছে ওখানে একটা ব্রাশ লাগিয়েছে ঠিকঠাক, প্রবাবলি কারেন্টটা ঢুকছিল না বেরোচ্ছিল মনে নেই। আর একটা ব্রাশ এমন জায়গাতেই লাগিয়েছে যেখান থেকে দুটো মানে দুটো এন্ডিং এ এসে ঢুকছে না বা দুটো এন্ডিং থেকে কারেন্ট বেরোচ্ছে না, এভাবেই লাগিয়েছে। এবং আউটার
না,
কয়েলেও
সেটা
সেই
সেটা
সমস্যাটা
সেটা লাগাতে পারে। সেটা হচ্ছে অনেক সময় আহ, মানে এই যে ইন দ্য other side of the coil, that thing happens. That means that both the currents are entering or both the currents are outgoing. That thing may happen on the other side of the coil. Okay, it's not at the commutator side, on the other side of the coil. Then that point is basically connected with the coil sides.
Sir.
Then we have two options. Okay, so yesterday also one of your friends asked me that issue, and I explained that. So হ্যাঁ, বলছিলে কি বলছিলে বলো? Anything else?
স্যার আমি যেটা করেছি হচ্ছে 3টে পোলের আন্ডারে 4টে কয়েল নিয়েছি আর একটা পোলের আন্ডারে 3টে কয়েল নিয়ে নিয়েছি। আদারওয়াইজ তো মানে ইন্টিজার নাম্বার অফ কয়েলস পার পোল
না,
তো হচ্ছিল না, তো আমি
you
সেটা
see
করেছি। সেটা কি
that
অ্যাকসেপ্টেবল?
will vary time to time, because that depends on there is instantaneous position you have drawn, so that keep on changing, na?
yes sir.
Okay, so that
What
is
I'm saying is, I mean, irrespective of the, suppose you take 3 slot for one pole and 4 slot for other 3 poles. What I'm saying is, any combination that you take, there will be possibility. I mean, otherwise circuit will, I mean, everyone will not be in series. You have two parallel coil in which all of the other coils will be connected in series. But if it is not the case in which one particular slot for two coil sides currents are not different, they will not be connected in series. I mean, if you see the figure or diagram, then you will see what I'm saying.
I'm not getting a problem, but it may so happen that one of the brush is placed, or you are forced to place one of the brush in a location where neither the all the currents are outgoing, not the all the currents are incoming. So it may so happen in case of wave winding, especially because in case of wave winding we face some problem placing the brushes. And this type of if you have seen that in two parallel paths, the parallel paths may have a different number of coil also. Have you seen that?
Yes sir.
So that you
Yes
cannot
sir.
manage
In one parallel
lap
path.
winding at all. In lap winding এ তুমি manage করতেই
Yeah.
পারবে না. Only the options you have in wave series winding.
Mhm.
Okay, so in that case, that problem may arise. Okay, so that brush position or brush location problem may arise, but that is generally taken care of like that. So you have to spare at least one coil side. Okay, সেটা তোমার একটা coil side কে spare করতে হবে, কিছু উপায় নেই। You cannot place the brush at the overhang end of the coil, isn't it? You have to place the brush on the commutator only. You cannot place the brush on the overhang end of the coil. Are you getting? Suppose, so this is the commutator end and this is the overhang end. Okay, so now if the current is like this, so you have to place the brush on this, but you cannot do this. Physically, it is not possible. It is not implementable. So you cannot place like this.
Yes.
So either you have to place on this or you have to place on this. So that you have to spare. Are you getting? So that problem sometime arise in case of wave winding only, not in case of lap winding. So I think this type of problem has arisen.
But what I'm no sir, direction of current is different. For example, in upper coil side, what you have drawn just right side of dummy coil, one current is going from left side to right side, and downside current is going from right side to left side. Then what will you do? How can it happen?
In a particular slot.
Yes sir, in particular slot. Yes sir, in particular slot.
It happening like this. বলো
Yes sir.
আর কি বলছিলে বলো?
স্যার বলছি যে স্যার বলছি যে পিএস বিমরায় মোস্ট প্রবাবলি এমনি ও যে কথাটা বলছে অমনি একটা এক্সাম্পল আছে, আমি কি একটু শেয়ার স্ক্রিন করে দেখাতে পারি? তাহলে হয়তো একটু বুঝতে সুবিধা হবে।
পিএস বিমরাতে আর্মেচার বাইন্ডিং রয়েছে। ওকে, সো ইউ ক্যান শেয়ার।
No, I have also PS Vimra.
আমি একটু শেয়ার করে দেখাতে পারি?
What is the page number? PS Vimra.
এই দেখুন স্যার।
What is page number?
স্যার দেখতে পাচ্ছেন পিকচারটা? এই দেখুন স্যার B1 এ এই কয়েল সাইডটা এদিকে কারেন্ট ডিরেকশনটা আছে, আর ওই কয়েলটাই তো কন্টিনিউ হচ্ছে, এদিকে কারেন্ট ডিরেকশনটা আছে। আমার মনে হচ্ছে ওইটাই বলছিল।
হ্যাঁ স্যার, আমি এটার কথাই বলছিলাম, এবং এই 11তে যে ব্রাশটা অ্যাড হয়েছে
এক্স্যাক্টলি
ওই করেই বেরিয়েছে পুরোটাকে।
না আচ্ছা ঠিক আছে, কয়েল সাইডটা ঠিক আছে, কয়েলে
আমি বুঝতে পারিনি এটা।
আর এই 11 নম্বর ব্রাশ পজিশনটা
না ঠিক আছে। ওকে, সো but you see, I was telling that in a particular slot, he's saying that in a particular slot two different current direction. That is not the thing.
না স্যার, তা না, একই কয়েলে দুটো সাইডে ডিফারেন্ট ডিরেকশন।
হ্যাঁ, একই কয়েলে দুটো সাইডে ডিফারেন্ট
এটা
ডিরেকশন।
ভীমরাতে আছে,
হ্যাঁ
বাট অনেকে এই জিনিসটা করেছে স্যার, বন্ধু মানে অনেক অ্যাসাইনমেন্টে আমি দেখলাম যে অনেকে একই স্লটের মধ্যে দুটো কয়েল সাইডে, একটাতে ডট একটাতে ক্রস, যাতে ওই জাস্ট কমিউটেটর সাইডটা মিলে। মানে হয় এইটাতে যেমন 3 নম্বরে যেমন দুটোই ঢুকছে, সেরকমই 11 নম্বর দিয়ে দুটোই বেরোচ্ছে, এরকম করার জন্য।
আমি বলি সেই।
আচ্ছা সেটা করেছো তুমি?
কিন্তু সেটা তো স্যার,
না সেটা তো মানে
সেটা কি পসিবল? মানে একই কয়েল সাইড, মানে একই স্লটের মধ্যে দুটো কয়েল সাইডে আলাদা আলাদা কারেন্ট ডিরেকশন?
ওইটা তো হবে না, একটা স্লটে তো দুটো সেম কারেন্ট ডিরেকশনই হওয়া উচিত।
হ্যাঁ, কারেন্ট ডিরেকশন তো সেমই হওয়া উচিত।
স্যার এই যে সমস্ত কয়েলে আবার এই প্রবলেমটা অ্যারাইজ করছে, মানে এই যেমন এখানে B1 কয়েলে, মানে আমি আরেকটা বই দেখলাম, ওখানে বলেছে যে এই কয়েলগুলো অ্যাকচুয়ালি ইন্টারপোলার রিজিয়নে থাকায় এগুলোতে যে কোনো ডাইরেকশনে কারেন্টটা দেওয়া যায় প্রয়োজন মতো। ওখানে উল্লেখ
এটা ঠিক আছে,
আছে মানে এগুলোতে অ্যাকচুয়ালি কোনো ইএমএফ ইনডিউস হয় না।
হ্যাঁ সেটাই আর কি, মানে ইনমেড ইনডিউসড হলে তো এটা তো কেসিএল ফলো করছে না। হাউ ইউ ক্যান শো লাইক দিস? অ্যাকচুয়ালি ইউ ক্যানট শো লাইক দিস অলসো।
হ্যাঁ স্যার, অ্যাকচুয়ালি
it will not follow the KCL না, how you can show like this? তো সেটাও সেই KCL টা ফলো করাতে গিয়ে ওরা অ্যাকচুয়ালি they have changed the direction of the dot and cross in a particular slot, isn't it? মানে ওরা যেটা করেছে, এই যে ফিগারটা আছে, এটা তো KCL টাকে ভায়োলেট করছে। You cannot draw like this. So therefore what they did, they changed the direction of the dot and cross in a particular slot, isn't it?
স্যার ওই
that is not possible, of course.
স্যার ওই বইগুলোতে মানে ওখানে আর রিয়াল ডায়াগ্রাম ড্র করেন, ওখানে ডেভেলপড ডায়াগ্রামের মধ্যে জাস্ট মানে যে কয়েলগুলোতে এই প্রবলেমটা হতে পারে তাদের দুটো পোলের মাঝখানে দেখিয়ে মানে প্রয়োজন মতো যেটা দেওয়া যায় সেরকম ডিরেকশন দেখিয়ে দিয়েছে।
Correct. Ultimately this will not participate in the voltage develop expression.
স্যার আমি একটা এক্সাম্পলে দেখেছিলাম যে যেগুলোই নিউট্রাল জোনটাতে থাকে, নর্থ আর সাউথ পোলের ঠিক মাঝামাঝিটাতে, ওখানে ওরা ডট ক্রস কোনোটাই দেয়নি, তো বললো যেহেতু নিউট্রাল জোনে আছে তো ইএমএফ ইনডিউস হবে না, তো কারেন্টটা জিরো। আমার মনে হয় এখানে ওই কারেন্টটা জিরো ওইটাই, কিন্তু ওখানে সিম্বল ডট ক্রস কোনোটাই দেয়নি ওটা নিউট্রাল জোনে।
that is correct, but uh, not always. So I will discuss today the commutation, then you will understand the thing. Generally, what in the purposefully the brush positions are kept in a location where the voltage induced will be least. Okay, মানে ইচ্ছা করেই ব্রাশটাকে এমন জায়গায় রাখা হয় যেখানে ভোল্টেজ ইনডিউসটা সবচেয়ে কম হবে। ওকে, সেটা কেন করা হয়?
Sir, this problem will not arise if number of slots are even.
Number of slots are even হলে তো আমি দিতামই না। So you can go
Yes sir,
for
ये
this
माने
lab
तब नहीं होगा
winding
ये,
also.
ऐसे जो हो रहा है अभी।
If the number of slots are even, you can go for
Yes sir, yes sir,
go for the series one.
and that's why you took always odd number of slot in your example and well as what you are showing us. Yeah.
Okay.
আর স্যার এই 11
হ্যাঁ।
নম্বর কমিউটেটর সেগমেন্টে যে ব্রাশটা অ্যাটাচ, ওর প্রবলেমটা একটু বলবেন যে কোনো কারেন্ট তো অ্যাকচুয়ালি এইটা দিয়ে মানে যেমন এই 3 নম্বর সেগমেন্টটাতে দুটো কারেন্টই এন্টার করছে, তাই জন্য এটা প্লাস করে দিয়েছি আমরা, কিন্তু 11 নম্বর স্লটে তো এমনি
No,
হচ্ছে
no.
না, একটা ঢুকছে একটা
Either
বেরিয়ে যাচ্ছে।
where you have to place the brush, actually, as per the diagram, you have to place the brush at B1, isn't it? Or this where this B1 is written. At that point, you have to place the brush, but you cannot place the brush on that location because that is comes and the overhang location. Are you getting? কি বলছি? তোমার ব্রাশটাকে কোথায় রাখতে হতো আইডিয়ালি? এখানে ব্রাশটা 11 এ থাকারই কথা ছিল না, ব্রাশটা থাকার কথা ছিল ওই কে বি, in between this k small k and b1, isn't it?
ওকে
বুঝতে পারছো? হ্যাঁ,
Yes sir.
বলছি সেটা না করে এবার হচ্ছে তোমাকে কোথায় রাখতে হবে, আইদার 11 এ or 6 এ। Are you getting? So that is
স্যার
the
আবার কয়েক জায়গায় 11-6 একসাথে কানেক্ট করে দেখিয়েছে স্যার, ওটা কি করা যায়?
11-6 একসাথে কানেক্ট করে দিয়েছে। ওই আলটিমেটলি তো
হ্যাঁ, মানে
তোমার
দুটো
কথাটাই
দুটো
হলো,
ব্রাশ
তো
লাগিয়ে তারপরে দুটো থেকে
আরে
কমন
ওই
কানেক্ট
কয়েলটার
করেছে।
তো কোনো দরকার নেই। So they have
হুম।
so if you short these 11 and 6, then this total whole coil will be bypassed. That's all. That will be again that will be clear from that diagram you are telling about. বুঝতে পেরেছো? এইটা ওই ডায়াগ্রামটা থেকে বোঝা যাবে যে
Yes sir.
হ্যাঁ, দেখবে ওই 11 আর 6 টাকে শর্ট করলে পুরো ওই কয়েলটাই বাইপাস করে যাবে, যে কয়েলটা এই প্রবলেমটা অ্যারাইজ করেছে, isn't it?
Yes sir.
Okay, so either you can place the brush on 11 or 6, because you cannot place the brush between K and B, because that comes in the overhang position of the coil. You don't have any access there. So anyway, you can stop the share. And so thank you for your sharing. So let me share. So I think you have gained some interest in this armature winding. It's very interesting, but for many years the students are not getting interest either in electrical machines or this type of detailed armature winding. I don't know why. অনেকদিন ধরে ছেলেরা এই ব্যাপারটাতে ইন্টারেস্টই পায় না, I don't know, but it's very interesting. And nowadays there are few people which are expert in this type of armature binding and machine design, especially in West Bengal. So that I know. So anyway, so আর কিছু আমি armature binding এ পড়াচ্ছি না, then I will start the new chapter for the commutation. So if you have any other doubt, you can ask me, and I will start the. So anything you have in your mind? right now. Okay, so I will start the discussion of commutation from this particular drawing that you have drawn for lab or wave binding. So you see, when actually the armature coils are rotating, isn't it? Like this figure. Okay, so let's start with this. So here you see this particular coil side, that is the 7. Now you see 1, 3, 5, all these coil sides are carrying dot current. And coil 7, 9, 11, these 3 coils will carry cross current. Now it is the instantaneous position of the slot or coil sides. But this armature is rotating. Suppose this armature is rotating as a generator in this direction or motor. I don't know in which direction I have taken. But suppose the machine in the armature is rotating in this direction. Okay, so what will happen? In the next instant, the 7 will come at the position of 5. Then what will be the current direction in the 7? And 5 will come in the position of 3. Are you getting? কি বলছি? Suppose after some time 7 will be here and 5 will be here, 3 will be here and 1 will be somewhere here. The next instant. Then what will be the current direction of 7 in that instant, in the next instant? Can you tell me?
Outward to the plane.
That means dot. You are saying dot.
Yes, sir. Yes, sir.
But at this instant it was cross.
Yes, sir.
So are you sure that it will be dot?
Because direction of magnetic field has changed
Direction of magnetic field hasn't changed.
for one particular.
Direction of
I mean, for
magnetic
one particular slot.
Okay, now direction of main magnetic field, that is the north pole, due to the north pole, south pole, etc. That hasn't changed.
Yeah.
Now, if that cross current in the 7 doesn't change at the next instant, now what will happen? The torque will change.
Some anti-torque will be there.
Magnetic torque will opposite. Okay, so that will create a problem of rotation. The torque, if the torque alternates, how the motor will rotate. So the to maintain the torque, unidirectional torque, the current which will flow in the next instant through the 7th coil side should change. Do you agree this? It should change from cross to dot. Do you agree this point?
Yes, sir. Yes, sir.
Otherwise, the torque will not be unidirectional. If the cross is also cross in the next instant, then the torque has to change. Okay, that you have to understood this point. So therefore, it's a necessity to change the current direction in a particular coil when it comes under a different pole from south pole to north pole. When this type of change occurs, then the current direction also must be changed. Otherwise, the torque will not be unidirectional. And to get a finite rotation, a finite speed, so you need an unidirectional torque. Okay, so that you have to understand. That means through this 7th coil side, At some instant it was cross current, in the next instant it is a dot current. So there is a change in current direction. Are you getting? Suppose for the cross current, the current is 5 ampere. Now the dot current, it cannot be 5 ampere. It will be minus 5 ampere. Now there will be some change from this 5 ampere to minus 5 ampere. Now this process of changing the current direction is called the commutation. Are you getting this point? This change of changing the current direction is called the commutation. Any point you have here? So if you have understood this, then I will open a new
Sir,
code.
স্যার বলছি ডেফিনিশনটা একটু লিখে দেবেন যাতে একটু মানে একটু সামারাইজ করে লিখে নিতে পারি কমিউটেশনের ডেফিনিশনটা।
Definition. Okay, so definition is the reversal of the current direction. That is called the commutation in a particular coil. Okay, you see, just write down. I am just telling you that the reversal of current direction in a particular coil is called the commutation. It's okay. So
Yes,
if I,
sir. Thank you, sir.
yeah, if I draw the simplified diagram. Now you have commutator segment like this. Okay, so let us take this 1, 2, 3, 4, 5 like this. And suppose the coils are like this between 1 and 2. You have some coil between 2 and 3. You have some coil like this. Between 1 and 2, suppose you have some coil. Now you have some coil here. Another coil is here, like this. So I'm not drawing the bigger coil like this. Like this, I'm not drawing the bigger coil. I'm only drawing the small coils like this, like the coil representation only. Okay. Now this is the coil number 1. So through which some current is supposed flowing in this direction. Suppose here the coil at this particular instant, the current is flowing in this direction, and here also the current is flowing in the opposite direction. Now can you tell me where the brush will be placed?
Sir, at 2.
2.
Exactly at 2. Okay, now what will be the current direction in this coil? Can you tell me? In the coil between 4 and 3, what is the current?
From the left to right,
sir. Left to right.
from
right.
left to right,
Correct.
left to right.
So left to right, correct. And if we have some coil here,
Right to left, sir.
Right to left.
so right to left, correct. So that means here, according to the KCL, the current should flow in this direction, and we have to place some brush over there. And let me assume, let us assume something, otherwise we cannot proceed with simple discussion. So let me assume that the width of the brush is same as the width of the commutator, one commutator segment. So let us assume that. Have you understood what is my assumption? That I can assume. So I am assuming that width of this width of the particular width of a single commutator segment is equals to the width of a brush. Okay. And between two commutator segment also you have some material. You know what is that? How this line, who forms this line or this separation? This separation.
Mica.
Mica.
Okay, so if you
Mica.
have gone through that experiment in the basic electrical engineering laboratory, then you should know that the separations are made by mica. So mica is a very good insulation and it can withstand very high temperature as well. So mica is used to separate two commutator segment, but that is very thin. For this particular exercise, we'll neglect the thickness of this mica. Okay, so I will neglect the thickness of this mica also, or this mica separation also, and I will assume that the thickness of the or the width of the brush is equals to the width of the uh, a single commutator segment. Okay, so at this particular position or state, the brush will carry how much current? 2, sorry, 2 IC, isn't it? Is it clear? বলো। Now, in the next instant, the commutator is basically, suppose the commutator is rotating. In which direction it is rotating? Let us say in this direction, the armature or the commutator is rotating. So that means brush is fixed in space. So brush cannot stay at that point. So then that means the brush will move. With respect to the armature, the brush, the commutator, the brush will move. Suppose the brush is moved at left. Okay, so let us draw the brush again. So the brush will move a little, and let us draw the brush here. Now what will happen? Can you tell me? Now the brush is slightly touching the commutator segment 3 as well. Whether the same current will flow now also?
Yes, sir. I think, sir, so some part of the current means it will not be exactly IC from the right hand side. It will be something less, and it will be somewhat more in case of the left hand side. But the current will remain same. It will be 2 IC.
Okay, so you are saying that this current will be, so as, so this current will be 2 IC, you are saying, huh? But there will be some
Yes, sir.
current in this, because you see the brush is now touched as a contact with the commutator segment 3. So some part of the current will be diverted to this 3, and this 2 also.
Yes, sir. Yes, sir.
Now
Yes,
previously
sir.
2 was sharing the 100%. Now the share will be a little with the 3, isn't it? Are you getting? If this is my coil 1, okay, so now this coil, so that means between 3 and 2. So this coil, one of the, okay, so this, so what will be the current in this current, and what is the coil current also? So that means this current will no longer be IC, but what will be this current? Are you getting? Suppose if this current is IC, if some current is diverted in this path, so this current will not remain IC. Suppose the current which is flowing through this is suppose I prime. Now what is this current? Then according to the KCL, this will be IC minus I prime, isn't it? Are you getting?
Yes, sir.
What I am doing, I am applying my KCL here. At this position, at this point, I am using the KCL. Now IC current is coming and I prime current is passing through this commutator segment 3. That means left to right, that is the coil current now will change and it will be IC minus I prime. Okay? Okay. Now, the next position. Okay, so it will be, now we'll have the equal share. Equal share, let me draw this. Let me draw this. So it will have a at a particular instant it will have a equal share with or equal contact with 3 and 2. Now what will happen in that? What will happen in that? Can anybody tell me?
Sir,
Sir,
can you
each
please?
path will IC, the current will be IC.
It has to be IC, isn't it? So if this is if this has to remain to
Yes,
IC,
sir.
so this has to be IC and this has to be IC. And what will be this current then?
0.
Correct. So that means there will be no current in this particular instant. There will be no current in this instant. So you have to understood this. That means the current is passing through its 0 value. The coil current, okay, anyway, suppose the coil current starts with a 5 ampere. So I have shown in the previous diagram, it starts with a 5 ampere, then it starts decreasing. Then at some point it will pass through 0. So this is the 0th point. The next instant. So it's a very easy to draw here, but in board it is not so easy. Just a minute. Okay. Now in the next instant, it will share more with 3 because it's moving in this direction. In all this point, the commutator is moving, not the brush, but relatively the brush will move with respect to the commutator. Now in the next instant, which I am showing here, here the current, or there will be more contact with 3 than the 2, commutator segment 3 than the 2. Now what will happen? What will happen? Now here the current, the less current will flow through this and more current will pass through this. So let me erase this. So here also the current will flow, but here the direction will change. Okay. Now let us take that some I double prime current is flowing in this path. Then, so it is IC. Then IC minus I double prime current will flow in this path, and this is I double prime, and this will be your what is this current will be? What will be this current? Can you tell me what is this current? Anybody? It's very easy.
2IC minus I double dash.
Okay, so this current will be 2IC. You just apply the KCL here at this point. So that will, okay, so 2IC minus I double prime current will flow in that path. So here also in the previous diagrams I missed to show that. Okay, so this is the instant where the brush is sharing more contact with segment 3, commutator segment 3 compared to commutator 2. But commutator 2 still has some contact with the brush. Now, the last instant which I will show, where the brush will be totally in contact with commutator segment 3, and so this is the rotation and it is completely contact with 3, then what will be the current direction? So there will be no current in this at all, and this whole current will pass through this coil, and this will be IC again. Are you getting? So that is the 5th position. So you just say this. So these are the 5 position. This is the position 1, 2, 3, 4 and 5. Now if we look at the current value only through the coil under commutation. So I think you have understood which coil is here under commutation. So if we see, if you observe the current under commutation, the current in the coil under commutation. So initially it was IC. In the first instant it was IC. Then in the second instant it was IC minus I primes. I prime has a finite value. In the second instant, in the third instant, it was 0. In the fourth instant, it is in the opposite direction, that is minus IC minus I double prime. And in the fifth instant, huh? কেউ কিছু বলছিলে? And if this total time is Tc is 1 to 5, it will take some time to go from 1 to 5. This time depends on the speed of the machine. Okay, so that time is called the commutation time Tc. And if I draw in a figure, so this time, suppose it was Ic initially, then at some instant it will be this value Ic minus I prime, and after that it will be 0. Then it will be having some opposite value Ic minus I double prime. Then it will be minus Ic at this point. So this is minus Ic, and this time is called the Tc, commutation time. Okay, so this is called the commutation. So this commutation time depends on the speed of the peripheral speed of the machine or the commutator, not only RPM but the peripheral speed of the commutator and the width of the brush. So these two are the determining factor of the commutation time Tc. So have you understood? Now this change of current from plus Ic to minus Ic value, this change determines different types of commutation. Suppose if this change also in my figure it is neither a straight line not a parabola, nothing. So if it is a straight line, if this line is particular straight line, then that is called the linear commutation. If it is a straight line, then it is called the linear commutation. Okay, but in most of the case the commutation doesn't remain linear. It either it look like this, or like this, or like this. So different type of commutation will have resistance commutation, we will have over commutation, we'll have under commutation. Okay, so that I will discuss in the next class. So what type of commutation we have for different types of situation. Suppose if the coil has only the resistance, then we'll get the resistance commutation which is like this. If we have only the resistance in the coil, then we'll get this type of commutation. Okay, and if we have some inductance the coil, then we'll get the under commutation. So this is the under commutation, and this is the over commutation. So this is how we can get different type of commutation, this type of change of current from plus Ic value to minus Ic value. So that depends on the resistance of the coil, resistance of the contacts. Contacts means the between the carbon brush and the coil there is a contact resistance. So it also depends on that. And there are different types of EMF can be induced. EMF can be induced due to simple LDIDT, that's the self inductance of the coil. So coil offers any coil offers a self inductance. So due to that self inductance, some EMF can be induced, or due to some speed EMF. Speed EMF, you know, for DC machine also you get the speed EMF. Due to the speed EMF also, there can be some EMF during the commutation. Though the commutations or the commutation must occur where there is no EMF induced. You should remember this point. So therefore we place the brush in such a location where uh, no voltages are induced. but it cannot be avoided always. Sometimes there is some voltage induced in the coil in the commutation region as well. So therefore, in that type of voltage, speed EMF, which is called the speed EMF, uh, what type of commutation we'll get, that I will discuss in the next class. So there are different situation, as I told you, that there are different resistances and different induced EMF, self-induced EMF or rotational induced EMFs. So we'll get different types of commutation. Okay.
Okay, sir.
Now let me stop the share.